and the LeetCode. Everyone, April the 10th. Alright, let's do this today. Remove k digits. Given string representing a non-negative integer and an integer k, return the smallest possible integer after removing k digits from num. A num does not have any leading zero except for the zero itself. But you can remove, right? You can remove to keep the zero. Consider only number of the digits. Okay, so at most we can remove k digits, right? So if we want to remove k digits, what do you think? Well. It can be any k digits, right? So I can say, because we want to keep it small, so we go from left to right. Well, I definitely go from left to right. Actually, it not necessarily always going from left to right, right? We should go look for, like we want the left side to be small, right? We want the left side, so because we remove k digits, right? If we remove k digits, then it will guarantee to be removing that many number of positions. So we want to remove as many positions as possible. So at most we can do is remove k positions, right? K positions. So if we go from the left, we check the first one, right? And then we go for the second and then go for the third. I mean, after we remove, we want to leave, or shall we say, we go through the things, we check to see the smallest value, right? We check to see the smallest value. Oh, hey, I'm doing good. I do this early today, because the previous days I always feel sleepy. All right, so because we remove k, right? We have removed k. So if we go from the left, not really left, if we can find out, like if we have a zero like deep down in here, right? If I have a zero deep down in here, we cannot remove it, right? Because it's just not possible to remove everything to expose zero. We want to expose, right? We want to expose the digit that is as small as possible. So in this case, I'm starting to think maybe we can use we can sort it, right? Can we sort? Can we sort? In this case, if we sort, we'll have 1, of course, 0, 1, 2, 3, 4, 5, 6. Okay, if we sort, right, then this will be the case. We'll have 2, 2, 3, 4, and 9, right? This is the result of the sort. So if we go through this, we want to expose the smallest. So we check the first one, it's a 1, right? So the smallest is also at the beginning. So if that's the case, then we don't really do much because we cannot get even smaller than this. So now I move on to the second one. This is a 5 at position 5, and we want to expose this. Well, if we want to expose this, we need to remove 0, 1, 2, 3, 4, right? We need to remove all of these. But yeah, since this is a 0, so we actually don't count the first one, right? So in this case, we don't count this one. So to expose this one, we need to remove 4 numbers. Now, of course, we cannot do that because we can only remove 3, which means this 1 cannot be exposed, right? No, we cannot expose this. So now we move on to the next one. This is a 3, right? So if it's a 3, then we need to remove 1, 2 to expose. So we remove 1, 2, right? We remove 1 and position 1 and position 2, right? We remove position 1 and position 2 to expose this. And the next one is a 2. Yeah, I don't think this is right? I don't think this analysis is right. So like you're saying you remove 4 and 3 and you remove a 2. I mean, in this case, we're saying we want to expose this. Right, I want to expose this 2 because it's the smallest, so I can remove the previous 2. Right, so we remove this, then I can expose this. Okay, so we expose this. And now we're moving on. This is another 2. How do we know we want to expose this? Because we want to expose this 1. Nah, I don't feel like it. I don't feel like it. Maybe we need to find some different way. Maybe it's a DP. I don't know. Maybe we can say, but if it's a DP, we have the position and then we have the K, right? It's kind of 2 levels. Doesn't seem to be a 2-level DP. We still need to analyze this, right? Still need to analyze this. How? So we start with I mean, what we can say, like each position, right? You can say each position is going to be removed or not removed. Yeah, but still, that feels... Let me think again. So we start with some stuff, right? And we will... Maybe, I don't know, a 1, a 4, a 3, pop in this, a 2, pop in this, a 2, and a 1, pop in this. That's the 3 pop. A monotonic increasing? Monotonic increasing. What do you think? Monotonic increasing. So we have a 1, 0, pop this. 2, and that's it. Because we only can pop 1. That's it. So 2, 0, 0. Huh. And 0 actually pop as well, so it becomes 2, 0, 0. Really? It's monotonic array? Because the gist of monotonic array from left to right is always if you find something smaller, or which is say you can expose something smaller, you will try to pop whatever is in front of you, right? Whatever's in front of you. And it will all, like if you can get exposed, you will always be able to expose yourself, because if there's any popping happen before, it's just popping all of those. Yeah, it's like, I think it makes sense. It makes perfect sense to me. Okay, so if we want to do this, how would you propose that we do it? can we do it without really creating an array? Can we do it in place? Not really in place. If we create, let's say an array, right? We have 1, 4, 3, 2, 2, 1, and 9. Okay. Can we do it like this? So like we have a pointer, right? So we pointer as here. That's the first one. Okay, now this is a j. It's larger than this, so we move on, and then we put I here, j here. J is smaller, so we pop, which means we'll put 3 here, right? And I will move here, and then j also move back. Then we compare. So we always compare this j compared to this, right? If it's larger than, then we're done. Okay, but then what? This one is done, so we need a k. We cannot use a k, so like a p. Okay, so we have so p has to keep moving forward, right? No, actually no. All right, so I think the challenging part is how do we do the monotonic array without set up a stack. Okay, so we need to have one pointer just keep moving forward, right? Okay, one pointer keep moving forward and the other pointer is at the head of the stack. So I is here, j is here, right? So we compare j position to I position. If it's bigger, good, j move forward. And then we append it, so I also move forward, right? And then we compare it smaller, then I will change into this value, I will go here, right? And then no, why does the I move? It doesn't make any sense, right? It doesn't. Hold on. It's we don't change the value yet. Okay, don't change the value yet. So I is here, j is here. Then we do the comparison, and then I move, and then it's not good. Then we append, so we put this here and put I forward. Yeah, so now it's here. Now j move forward, right? It's a 2, so it's small. Then I need to pop, so which means I coming here. Compare, it's bigger, so this one become 2. All right, and the number of popping is just how many times I have moved back, right? How many times I have moved back, and each time pop, k, yeah, and then j move forward, equal, so I is here, don't do, and then j move forward. Oh, this is smaller, and then we're gonna pop because we have k, so we have pop. All right, and then this is oh no, I have to move. Oh, I have to move forward. Yeah, I always move forward and I set this position here, right? So I is here, and then j is here. We compare, and then I say I moving down here. This get popped, and then this is still smaller, but we don't have any more k, so we say we end, and then we put 1 here, and I move here, right? And then j and 9 is larger than this, we don't do, so we just append. I come here, 9 come here. So we have 1, 2, 1, 9 with I come here. So at the end, what we do is we will slice it to this. I forgot how to do slice in Java, so we're gonna have to go back to that. But let's try monotonic. Yeah, it might actually work, huh? Okay, so what we're gonna do is a char array new num dot not new num dot, just num dot to char array. I is 0, right? And then we say for int j is 1, j is smaller than array.length j plus plus, right? And then what we do is while array j, okay, is larger than array I and k is larger than 0, right? When we do that, what do we do? When we do that, we say I minus minus, because we pop the I, and then k minus minus, because we remove 1, right? We remove 1. And then we keep going until we're done, right? Once we're done, we say array plus plus I, because I move forward, that will do array j, right? And then we'll keep going, and then at the end, we'll return arrays dot to string. No, string dot value. String dot value of. Now we need those Java. Yep, same thing. Copy range. Copy range. Sublist. I don't think that's the, wait, hold on. Converting part of char to string. Yes, this is the one. String. Ooh, look at this one. This one looks like the one I want. New string char array int from the characters of array A starting offset 2 and the length. So this is the offset and this is the length. Okay, so if I want to do this, I can say return a new string, right? A new string of array with starting as 0, the length is I plus 1. Alrighty, give this a go and see how this one goes. Does it work? No, of course not, because I need to be larger than 0. So while I is larger equal to 0, and this, okay, forgot about the I. Okie dokie, that is not right. That is absolutely not right. All right, let's see what happened. I removed 1. Wow. That is... Oh, my bad. It should be smaller. You're doing monotonic increasing. My bad. Now I'm just doing the maximum. Okay, 1, 2, 1, 9. And now the only thing that we need to worry is we need to remove all the zeros. Right? We need to remove all the zeros. So what we do at the end... Okay, yeah, this is something we need to do. So once we're done with this, and we need to have int j is equal to 0 while array j is equal to 0 j plus plus. And then at the end, we're going to start from j. The length is not this. The length is going to be I minus j plus 1. Something like that. Something like that. So we need to remove the leading zeros. J is smaller than equal to I, and now what I'm afraid is it will become an empty array at the end, right? Yeah. So maybe what we can do is J smaller than I, then we are guaranteed to, like if J is smaller than I, so whatever it is, if it's one digit, right, we'll always leave it. So that we can get to the correct answer. Okay, let's see if this one's correct. Have a little bit faith, not a lot. 402. Monotonic increasing array. Let's see. No. Yeah, all right. Okay, we'll do this. And then return this. Okay, we say J is smaller than I. Otherwise, we return 0. How about this? How about this? No! Wow, that was pretty bad. 112 output. Wait, what? Alright, this is some coding issue. There's some coding issue. How come you didn't get rid of anything? And then J move forward. Oh. Okay. Yep. I see what this one is. This is just how did I miss this one? So in this case, everything's going up. So you just need to remove from back to front, right? From back to front. I guess we have to, okay. So we remove the leading zeros, right? We remove the leading zeros, that's necessary. We remove all of them. And I think the edge case we can just go, like we can say if J is equal to I, that's the edge case. Right, then we just return 0. And then it depends on if we have any k left. If we have any k left, we have to go from right to left because everything is from small to large, right? So we're gonna start from J, we're gonna end at not at this, but I minus k minus J plus 1. So whatever k I have left, right? Whatever k I have left. If there is more k left, we always remove from the right because because array all the way to I plus 1 is already non-decreasing. How about this? Wow, look at last time we solved this in one shot. Okay, that is not right. Which one? Yeah, this is the issue with, I think, the 200, right? So you cannot remove. Wait, which one we have an issue? 2? This one? It shouldn't. Or we should do it this way, right? We do this one here. And then we say I minus equal to k. Right? Remove leading zeros. And come out if j is larger or equal to. I mean, it's not really possible to be larger or equal to, right? Yeah, it's possible that we don't do this, then we hit this, right? Then we hit this. Then at the end, we will just do this. Is this one good? We happy? Yeah, it looks like we happy. Looks like we happy. Okay, let's try. See if we happy. We happy? No, we not happy. How are we not happy with this one? Oh, so it does go to, oh my god, so shoot. I think it should be j larger than I. Right? It should be, okay, that's okay, so j smaller than I plus 1. Man, but it's the same thing, right? It's the same thing. Because we can only go all the way to here. And then when we check, if j is larger than I, then we return this. Which means we go beyond. And that's an empty. But if we don't, we'll return whatever is the last one. Alright, are we happy? Come on, we happy. Let's be happy. Yes, now we happy. Wow. 4 attempts. So it is monotonic array, but due to the way I'm implemented, it's there's a lot of more edge cases that I have to consider. A lot more. Actually, I don't really think. I think this k, I definitely didn't consider this. I forgot about this completely. Here is also a little bit confusing to me. Yeah. I don't think I can blame it on how I implemented. It is the right way. Oh, that's why it was easier. God, Lord. You're able to do that, and then you can just join them. Oh, at the end I have stack.pop. Oh yeah, because we added one more, so we have the pop at the end. Oh, you see what you did there? You add a 0 at the end, and because you add a 0, that make it easier, right? That make it easier because if there's anything, yeah, so this one handles the k. If there's extra k, this one will handle it. So I don't have to go through this. I don't have to go through this. But how about the leading 0? How do I deal with the leading zeros here? Oh, you're kidding me. I did an int and I did an str. Got it. That's all right. I know what I did there. Okay, so what's good? Right? We done this? All right, I come back to this. So I had an idea of how to do this. So let's see if it will work. So we will first, let me reread this question. The number of houses on a number of line, right? Given a 2D integer array offers is from start to end. The ith buyer wants to buy all the houses from start to end for gold, amount of gold. You're a salesperson, your goal is to maximize your earnings strategically. So yeah, so we have these ranges, right? We have these ranges. And we want to do, and since each house can only be sold once, right? Cannot buy the same house. And the same house may remain unsold. So to maximize basically means if you have a range, right? If you have a range, you say, I want to sell the people, because the people want to buy this, right? I want to sell to this person, right? Then I cannot sell to this person, like the overlapping person I cannot sell. What I can sell to is the person that's not overlapping, right? So what I'm trying to think is we will sort this based on the end, right? I like to think to sort it based on the end, so based on the second value. And then we can say a DP, right? DPI will be the max profit or the max earnings, right? Max earnings selling, right? Selling a house, selling a range, ending at I. We're selling a house ending at I. Okay. So what we know for sure is in this case, I will get gold, this amount of gold. And then what I want to know is at this point, right before it, what's the maximum? So if this is a k, then dpi shall equal to whatever this value, the gold, plus dpk. So we need to know this dpk. All right, now what is dpk? What we can do, well, dpk, if dpk is also the end of a range, then we compute it. If dpk is not an end of the range, so like this is a previous range, right? This is the current range, and we want to sell here, so we need to know this one. So this is k. So what is this value? This value should be the same as this value, 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 right? So if, and also, if you are here, right? Awesome, by the way. If you are here within a range, if you're within this range, you cannot, or can you, sell this one? But it doesn't matter, right? If I sell this, then I have to consider this. So this doesn't matter. So here will also be the same as this, right? Also be the same, because if I sell a house like this, if I sell this one, then when I check this, this should be the same as the previous one. So yeah, I'll sort this based on the second value, and I'll go through this one by one, okay? And I actually no, I go through this I go through this start and end, right? I go through start and end. I just go through them one by one. And then the start will always be 0, right? The first one will definitely be 0, unless that first one is a 0. That's a different question, right? So how do I handle the first value? Well, I can do a pre. We can definitely do a pre. I can set pre equals 0, and then I'm at the first position. Then I just to see, I have indices here. So I have indices here. So if these two are the same, then I run some algorithm to get whatever it is right now, and I move to the next one. If the next one is not the end, so I'll equal to the pre. If it's not the end, we go to the pre. Not the end, equal to the pre. Okay. So let's try. Let us try. This is 2830. Imagine year 2830. Where will we be 800 years from now? What is 800 years before? 12th century, 11th century. 11th century, wow. 11th century is very, very old, ancient. Okay, so what do we say? We need a DP. Okay, so DP are equal to, but before we do that, oh, I have n. N is the total number. Okay, so DP equal to 0 times n. Okay, and offers dot sort key equal to lambda tuple, and we will do tuple 1. Okay, so offers are sorted, and then we have index is 0. All right, then for I in range n, actually no, I would like to check. Here's what I would say. If offers 0, 1 is equal to 0. Actually, no, because there can be many offerings at 0, so you have to consider that. Then that means we unfortunately have to do this. Okay. All right. So basically, we are here, right? And we need to check if is equal to, right? You got it. So while I smaller than length of offers, and if it's equal to, right? If it's equal to, so we can say while index is smaller than len offers. Oh, and offers index 1, because that's the end, right? If that is, now I'm just thinking, what's the information about the start? It doesn't really matter. It does matter. So if that is equal to I, okay? So when this, wait, hold on. We don't have this. When this happens, so the end is equal to the current one, then what do we do? Well, what we do is we will check its price plus the previous price, right? So we can say dp I equal to maximum dpi, okay, and offers index 2 plus dp. Actually, this is going to be like this. dp offers index 0 minus 1. Dude, this is way too complicated. I need to do another one. So we can say j equal to offers index 0, okay? And we can do here, let's just delete everything. We can say dp j minus 1 if j minus 1 is larger or equal to 0, else 0, right? So we do that to find its dp, and every time when we're done, index plus equal to 1, because we need to move forward, right? So if it's good, we handled it, index move forward, we try it again, until we get end, we get out, okay? We get out, then we try the next I. So while this, awesome, okay, and we should also handle a situation that actually we shall do is, let's do -1, right? Let's do -1, and actually no, because we need to say if this one never happens, right? If this one never happens, because if it happens, so you'll get some value, right? Actually, we can check. Is it gold would definitely be larger than 1. So if after this you are still 0, that means you have not done anything here, right? Then we just say if dpi is still 0, that means you haven't done anything. Then we say dpi will equal to dpi -1 if I -1 is larger than 0, else 0. Again, we have to use this to take care of situation that the first one, right? The first one, because it doesn't, the I -1 doesn't exist. Actually, I think we can do it here. If this is equal to 0 and I -1 is larger or equal to 0, then we just do this, right? I don't have to worry. This should be good. Right, we just copy the previous value. Copy the previous value. And then at the end, we shall return the maximum. Okay, we can return the max of dp. Okay, let's give this a shot. Is it right? Okay. It might be right. Okay, let me write some stuff here. So basically, actually, I don't like it right here. Let's write it here. All right, so I say dpi is the max earning. All right, max earning when selling an offer whose end is I. End is I. Okay, so to when selling this when selling this offer, we cannot sell any other offers whose end is within offers within the start, within the range, within the start and end of the current offer, right? Thus we need to find the max earning when selling at the house at position start -1, right? Start -1. Any house, yeah, start -1. Or so DPI shall equal to DP maximum DPI, right? Plus not DPI, and then current earning plus DP start -1 for the houses that do not coincide with an end position. Its max earning is the same as its left neighbor. Yeah, it's the same because you cannot sell. You're ending at this, right? You cannot sell. Yep, I think this. I think this will work. Oh. Let's give this a shot. Let's see. Come on. And it does not work. All right. Full of confidence and it doesn't work. That's all fine. That's fine. I think we can try to take a look. All right. The man can debug it, but let me do this. Expected 16, right? I'm only getting 15. That's fine. Let's do this. We'll do. And this shall be just solution. 4 16. Okay, we have n and offers. This shall be maximize the profit. Offers. Okay, I think we can debug. Let's debug this. F5 Python the launches file. Oh, I didn't put a breakpoint. Let's move all the way down. Okay, so this is the offers. It's sorted. And we have, where is DP? DP's here. Okay. All right, let's try. This is, I think it's F5 is going down, right? No, I think it's F1. Yep. Okay, so I is not 0. Okay. And then offers 0, 0, that is true. We'll go in. So J equals offer, so J equals to 0. Okay. And the DP 0, we equal to maximum DP 0, and offers we have 6 plus 0, so DP will be 6, right? And index plus equal 1. And then it's false. Get out. DPI equal to 0, no. So I keep going. I equal to 1. Now I equal to 1. Index smaller, and then this is good. So j will equal to 0 as well. Ooh, j equals to 0 as well. Okay, yeah. And then dpi will equal to this, and offers, and j is 0, so I cannot use will be 0. So that's 5. Yeah, that's 5. And then this one plus plus. Now it jumps out. That's good. And I is equal to dpi is not equal to 0, so I don't do this. Okay, move on. I is 2. Okay, so this is in. J is equal to 1. Right, j is equal to 1. And dpi will be basically the current 8 plus dp 0. The dp 0, so that'll be 14. Right, that's 14. Okay, that plus equal 1. And then now we want to sell 2 and 2. Right, we sell 2 and 2. And if we do that, j is equal to 2. Right, j equal to 2. So to dp1, 1 is 5. So 5, that's 10. So it doesn't change, still 14. Now move up. Now j becomes 0. Okay, and then this is going to be 8. So still doesn't do anything. Okay, so get out. Now it's false because we reached 3. So get out, don't do anything, back up. So now we're at 3. The first one doesn't work because it's just a 7. Okay. Oh yeah, we do a 7. The second one is j is equal to 2. Right, so we're going to do 1, dp1. So dp1 is 5. 5 plus 2 is 7. So it's still 7. Right? Now index move on. Now it's a 2, 3, 10. Right? 2, 3, 10. So if it's a 2, 3, 10, I say then be 1. So that's 15. There's where the 15 is. Yeah, that's where 15 is. And then the last one is 0 to 3. We sell for 2, and that's not going to work. So at the end, we get out. So the answer becomes 15. Okay, question. Where did we go wrong? Or, you know what? A better question is, how do you get to 16 out of this? How do you get a 16 out of this? Oh, I see. God, lordy. I know exactly what went wrong. So instead of this, this shall be a mono. So dp, okay, so another thing, dp equal to this. Its max is this, not the same, right? A house do not naturally know for each house. So after done with the dp, okay, we'll do this here. So after the dp computation, or not, if the current house is not an AND to an offering, we have to keep dp none as a prefix prefix max, right? As a prefix max, which means after we do this, and dp shall equal to the maximum of dp I and dp I minus 1. Yep. This, I think... Ugh. Alright, this will be right. Oh, if we do it this way, we might as well just... Huh. That ain't right. It's still... How? Oh, yeah, it's this. It doesn't have to be 0. You keep doing this. Right, yeah, there we go. Alright, come on. You got this. Right? Yeah, that is correct. Oh shoot, it's log n. Damn it. I forgot a sorting part. Wow. Oh, it's not bad. Well, took one shot, right? And then we got it. Good questions, really good question. Oh. Binary search. You don't even need to sort? Oh, you don't even need to sort. How? I mean, yeah. But, well, I guess you don't need to sort. Interesting. Very interesting. They don't sort. He doesn't sort. And as a binary search solution. And log n binary search. I don't know how to think about this. I mean, I can definitely see, like, if I use the and. Yeah, I can see. You can do without sorting. Yes. You can definitely do without sorting. Actually, this is actually also not right. It's a sort plus n plus m. Because you go through every single one, right? Yeah, I can see that. But to me, sorting is, I like sorting better. I'm pretty sure he might use a map, right? Something like this, so that you can isolate for each position. You can know what it's related to, right? You can isolate it and then you just go through. Everything else is the same. Everything else is the same. And you don't need to sort. Okay, let's just take a look. Convince me that that is the solution. You will need, there's a DP, that is that. Yeah, so that's what it's doing, right? That's what it's doing. And then for this, oh, we don't need to do, yeah, that's actually true. We can, okay, we'll submit another one and we can do this one. That's true. That's good. Very good. Very, very good. Yeah, yeah. Yeah, yeah, that's good. Okay, so what we're gonna do is we can save one and note. There is a way. There is another implementation of this solution that uses extra space to reduce the runtime to O n plus n. Using the extra space as a mapping, right? As a mapping to quickly find what offerings are associated with a specific house we do not need to sort. It's not difficult to implement, and I will skip it. Okay, let's do this because I changed the thing a little bit, and we're gonna just do it this way. Oh, Java. What? Java. Yep. So we do, wait, hold a second. That's not what we want. Wait, we want a new thing. Or this is what we want. All right, let's see if this can be a little bit faster. Yeah, that's how I expect it to be. But yeah, that's good. So we just use this, right? We don't have to do the max again. Good. Okay, I'll leave this for tomorrow. Find the longest equal subarray. I'm not gonna even read this. All right, I'll see you guys tomorrow. Adios.